Lesson Managing AI Model Life Cycles. Managing AI model life cycles is a critical aspect of machine learning operations, a domain that ensures the successful deployment, maintenance, and evolution of machine learning models in production environments. Effective management of AI model life cycles involves a series of well-coordinated steps, including planning, development, deployment, monitoring, and refinement. These stages are crucial for maintaining the model's relevance, performance, and alignment with business objectives. By leveraging practical tools, frameworks, and methodologies, professionals can address real-world challenges and enhance their proficiency in managing AI model life cycles. The life cycle of an AI model begins with the planning phase, where the objectives and requirements of the model are clearly defined. This phase involves identifying the problem to be solved, understanding the data available, and determining the success metrics. A well-defined problem statement and success criteria are essential for guiding the subsequent phases of the life cycle. It is also important to consider the ethical implications of the AI model, ensuring that it adheres to principles of fairness, transparency, and accountability. Once the planning phase is complete, the model development phase begins. This involves data pre-processing, feature engineering, model selection, and training. Practical tools such as Jupyter Notebooks and libraries like scikit-learn and TensorFlow are invaluable during this phase. These tools facilitate experimentation with different algorithms and hyperparameters, allowing data scientists to build models that best fit their needs. For instance, scikit-learn provides a wide range of algorithms for classification, regression, and clustering, while TensorFlow offers robust capabilities for building deep learning models. After a model is developed and trained, it moves to the deployment phase. This is where model operationalization occurs, transitioning the model from a development environment to a production setting. Containerization tools like Docker and orchestration platforms, such as Kubernetes, are commonly used to streamline this process. Docker allows for the creation of lightweight, portable containers that package the model and its dependencies, ensuring consistency across different environments. Kubernetes, in turn, manages these containers, providing scalability and high availability. Deployment is not the end of the life cycle. Continuous monitoring is essential to ensure the model's performance does not degrade over time. Monitoring involves tracking metrics such as accuracy, precision, recall, and latency. Tools like Prometheus and Grafana can be employed to collect and visualize these metrics, aiding in the detection of issues such as data drift or concept drift, which occur when the statistical properties of the input data change over time. Addressing data drift is crucial for maintaining the model's predictive power and relevance. When monitoring reveals performance issues, the model may need to be refined or retrained. This involves revisiting the data preprocessing and feature engineering steps, adjusting the model architecture, or incorporating new data. A/B testing frameworks can be useful during this phase to evaluate the performance of different model versions in a controlled manner. By comparing the outcomes of two or more models, data scientists can make informed decisions about which model to deploy. Effective management of AI model life cycles also requires robust version control and collaboration practices. Tools like Git and platforms such as GitHub or GitLab enable teams to track changes to code and models, collaborate on improvements, and maintain a history of modifications. This is particularly important in environments where multiple data scientists and engineers are working on the same project, as it ensures that everyone is working with the most up-to-date version of the model and prevents conflicts or duplication of effort. In addition to technical challenges, managing AI model life cycles involves addressing organizational and cultural factors. MLOps requires collaboration across different teams, including data scientists, engineers, and business stakeholders. Establishing clear communication channels and fostering a culture of continuous learning and improvement are essential for the success of MLOps initiatives. This can involve regular meetings, workshops, and training sessions to ensure that all team members are aligned and informed about the latest developments in AI and machine learning. Case studies of successful MLOps implementations provide valuable insights into best practices and common pitfalls. For example, a study by Breck et al. Highlights the importance of automated testing and continuous integration in maintaining model performance and reliability. By automating tests for data quality, feature extraction, and model predictions, organizations can quickly identify and address issues before they impact production systems. Additionally, the study emphasizes the need for robust documentation and knowledge sharing to facilitate onboarding and collaboration among team members. Statistics also underscore the importance of effective AI model lifecycle management. According to a report by Gartner, organizations that fail to implement MLOps practices risk seeing up to 85% of their AI projects fail to deliver the expected outcomes. This highlights the critical role that structured lifecycle management plays in unlocking the full potential of AI and machine learning technologies. In conclusion, managing AI model lifecycles is a multifaceted process that requires a combination of technical skills, practical tools, and organizational strategies. By following a structured approach that includes planning, development, deployment, monitoring, and refinement, professionals can ensure the success and longevity of their AI models. Leveraging tools such as scikit-learn, TensorFlow, Docker, Kubernetes, Prometheus, and Git, along with fostering a collaborative and learning-oriented culture, are key to overcoming the challenges of MLOps and achieving sustainable value from AI initiatives.